Hello guys, in this video I'll be teaching you electronegativity and types of bonding. So this is already a slight advanced version, so let's do one for beginners. There are three kinds of bonds you should definitely learn about, like three basic ones. We have ionic, which is a metal plus a nonmetal. So metals, once again, include all the way here on the left. Note that I'm not including hydrogen. Hydrogen is the lightest element which runs on the left, but it is a gas or a non-metal. So this is an ionic bond. One example is sodium chloride, because sodium is an alkali metal and chlorine is a halogen, which is a gas or non-metal. With that being in mind, let's look at the second one, which is called covalent bonding. Covalent is between two non-metals. Covalent bonding, like one example can be carbon dioxide. So we have CO2. This is a sharing of electrons. Carbon dioxide is a sharing of two electrons, and it's two nonmetals. Now we have the third one. The third one is not that common, so you don't have to worry about it, but it's good to know about it. So we have metallic. We have metallic bonding. Metallic bonding is just two metals. So if I gave you a question and asked you, what would the electronegativity of sodium chloride be? So I'll explain this to you. This is the polar electronegativity values for the elements. So you see these numbers, like hydrogen is 2.1, beryllium is 1.5, lithium 1, right? So based on these numbers, you find the positive difference, not based on the order of the chemicals that are made, the positive difference. So with that in mind, if you'd like to try on your own, you can go pause the video, but I'll just show you the solution. So since 3 is greater than 0.9, you subtract 3 minus 0.9, which is 2.1. The electronegativity is 2.1. Now for beginners, when they look and I ask them what is sodium chloride, they'll say it's ionic. And that is true, but if you want to be more advanced or specific, you should use a line or like the scale. So I'm going to include 0.4 here, and I'm going to include 1.8 here. So if you're here, this will be called covalent if it's before 0.4. I'll get to an example when it's exactly 0.4 on the line. This is not ionic. This is called polar covalent. And here's ionic. This is why metallic is almost not heard of, but still, you should know this. So, in this example, they'll say it's ionic, and the beginner is right. It's 2.1, which means it's greater than 1.8, so it's ionic. So, what happens if I put phosphorus and chlorine? Now, most people would think, okay, so it's covalent because it's two nonmetals. And you're not necessarily wrong on that. But if you want to be more specific, let's find a positive subtraction, which is 3 minus 2.2 for phosphorus chloride. So it's going to be 0.8. But is that covalent? No, it's not. It's greater than 0.4. So it's going to be polar covalent. So PCl is actually polar covalent. So that's not just covalent, it's polar covalent. This is the most specific answer that people tend to prefer on. Now I'll answer a question you might be in your mind. What happens if the electronegative is right on the line, like right at 1.8 or right at 0? There's different opinions based on this, but in my opinion, I would recommend both of them. Like for 1.8, polar covalent and ionic, and for this one, covalent and polar covalent. Now I'll give you one example to try. This one's relatively easy. Cl and Cl. This is obvious, right? It's just 3 minus 3, which is 0, right? So it's obviously covalent, right? when you see a 0, you can say covalent, or you can say it's purely covalent because it's at 0. So I hope you found learning about electronegativity and bonding interesting, and thank you for watching, and don't forget to subscribe.